Hello everyone, and welcome back to K-Tips. In today's video, I'll show you how to set up a dev container in VS Code with Docker to develop a web application, both front-end and back-end, inside the same environment. We'll implement the front-end using Node.js and the back-end using Python. This means you won't need to switch between environments, which is a huge advantage if you're a full-stack developer or working with multiple programming languages and want to keep things simple. It's also great for those who work in between, like ML engineers, who sometimes use Jupyter notebooks to analyze data, train, test, and validate models before embedding them into an application. Additionally, it's ideal for resource-limited systems. This video covers a quick setup for beginners, but if you're interested in using multi-stage builds or Docker Compose for a similar workflow, make sure to subscribe. I'll cover those in upcoming videos. Stick around until the end, as I will also showcase how to publish your project to a GitHub repository. Now, let's jump in. To get started, you need to have 1. Docker installed. Visit the link appearing now if you need guidance on installation. 2. Visual Studio Code installed. The link with the installation steps should be appearing now. The first thing I want to do is start Docker. I'm working on Windows, so I right-click on the Docker icon and run it as administrator, then confirm when prompted. Docker is now up and running. Next, I want to create a new folder for the project. I right-click on my desktop and create a new folder. I'll call it k-tips_python_react. Then, I'll open this folder in VS Code by simply dragging and dropping it onto the VS Code icon, which opens it as the root folder in my working environment. Inside this folder, I'll create subfolders. The first one is for my front-end. You have two options to create a new folder. Open a terminal in VS Code and use the mkdir command. Click on the new folder icon in VS Code and manually create the front-end folder. Next, we'll create the backend folder, where we'll implement our Python application. Let's call it Backend. Inside this folder, I'll create an app folder. This is the structure I like to use when implementing a Python application. Inside the app folder, I'll create main.py, where I'll write the code for my first API. Now, I create a .devcontainer folder. This folder is a convention used by VS Code to define a development container, dev container, configuration. It contains settings and files that allow you to set up a reproducible and isolated development environment using Docker. VS Code automatically looks for a .devcontainer folder in the project's root directory when opening a dev container. Inside this folder, let's start by creating the Dockerfile. If you need detailed information on Dockerfile basics, check out the link appearing now. Next, let's create a file named devcontainer.json, where we define the container's environment. You can specify the Docker image you'd like to use, and if the image is available on Docker Hub, it will be pulled during the dev container build. In this video, I want to show you how to customize a Python base image to also include Node.js inside the dev container. So, we are going to use a Dockerfile to define the necessary instructions to achieve this. The next file I like to add inside my .devcontainer folder is a list of dependencies needed to run my Python app. I call it requirements.txt, and here I'll add FastAPI, since it's the framework I want to use. I'll also be running this API using Unicorn, so I'll list the Unicorn library in my requirements.txt as well. Now, let's edit the Docker file, starting with the from instruction. We use Python 3.11 Bullseye as our base image. Next, we set the arg variable Debian_frontend to non-interactive. Then, we install our dependencies. We start by installing Node.js. For this, we follow the steps from its official GitHub repository. Node.js 23.x is compatible with Debian Bullseye 11, so I will kind of Dockerize the installation instructions they propose. First, let's update the package lists in our Debian-based container to ensure access to the latest package versions before installation. Then, we install curl, which we'll use to download the node source setup script for Node.js 23, saving it as nodesource_setup.sh, as recommended in the official manual. I'll include a link to this page in the video description. Next, we run bash nodesource_setup.sh, which executes the node source setup script to configure the system for installing Node.js 23. Finally, we complete the installation with apt-get install Node.js. Now, let's move on to the Python dependencies, FastAPI and Unicorn. We copy everything from the current directory into the container's working directory, both referenced as dot. Then, we install the Python libraries listed in requirements.txt using pip, ensuring that no cached packages are stored during installation. Our basic Dockerfile is now ready to use. Now, we need to edit the devcontainer.json file, which is written in JSON format. We start by giving a name to our container. I choose k-tips Python React. Do you like this name? If so, like the video and leave me a comment. In the build section of this file, we specify how the development container should be built. The key Dockerfile with the value Dockerfile tells VS Code to use the Dockerfile in the same directory to create the container image. This is the file we edited previously. Now, let's prepare VS Code to build the dev container. VS Code provides an extension marketplace where we can find the necessary tools. Let's select the extensions icon on the left side of the IDE and search for remote development. This is a pack of 4 extensions: WSL, dev containers, remote SSH, remote tunnels. We install the entire pack. If the installation goes well, we will be prompted to reopen the project inside a dev container. This happens because we have the .devcontainer folder in the root of our project. When the remote development extension is installed, VS Code automatically detects this folder and suggests opening the project inside a container. If you don't see this prompt, you may have a typo in the folder name or a misconfiguration. Double-check your steps. Since we will be implementing a Python application, let's install the Python extension pack. This includes Pylons and the Python debugger, which will help during coding. Once installed, I add these extensions to my devcontainer.json to ensure portability. For the frontend, we'll use Node.js. The extension I love to use for JavaScript and TypeScript coding support is ESLint, so I search for it, install it, and add it to my devcontainer.json as well. Let's also add the remote development extension to this file. You can verify that the extensions have been added when you see the new customizations section appear in the file. One of my favorite extensions is the one that allows connecting to SQL databases like MySQL or PostgreSQL directly from VS Code's terminal, so you don't need a separate interface when working with databases. Do you have a favorite extension? Let me know in the comments. Let's continue with our tutorial and open this project inside the development container. To do this, I go to the bottom left of the IDE and click on the blue symbol to open a remote window. Then, you will see Reopen in Container appear. If it's not appearing for you, try typing it in the command palette, Ctrl+Shift+P or CMD+Shift+P on Mac. Select it, and VS Code will start building your environment following the instructions specified in the configuration files. It will pull the base image and then build the development environment. You know that you are inside the development container when you see the dev container key at the bottom left, followed by the name you gave to the dev container, in our case, k-tips Python React. Now, let's check the npm version since we installed Node.js. The installed version is version 10.9.2, or whichever version is currently installed. We use npm to initialize the front-end application using the Vite React template. We navigate to the front-end subfolder and run npm create vite at latest --template react. Once initialized, we install the dependencies for the front-end using npm install. Then, refresh the folder, and the files created for the frontend will show up. To automate this process, we will edit the devcontainer.json file and add the post create command section. This command runs after the container is created, changes the directory to the frontend folder, and installs the necessary Node.js dependencies listed in package.json using npm. This ensures the frontend environment is set up automatically each time the container is rebuilt. When you modify the devcontainer.json file, you may be prompted to rebuild the container. If not, you can press F1 or the corresponding command for your system, then select Rebuild without cache. You can also rebuild with cache if suitable. It will make the build process quicker. The post create command is now being executed. Once npm install is done, you can exit the execution terminal by pressing any key on your keyboard. At this stage, we have both Node.js and Python ready in our dev container, so we can start coding. I'll begin by implementing the backend with a simple Hello World FastAPI application. First, we import FastAPI from the FastAPI module. Then, we declare our application as a FastAPI instance. Thanks to the Python extension we installed earlier, coding is easy. We mostly just select the suggested completions. Next, I implement the homepage of my application using a get method, which works over the HTTP protocol. I define a function that will be executed each time a user visits the corresponding URL. I call this function k or tips_root. It takes no parameters and returns a JSON response with a key message and the text hello k tips community. I also define another get endpoint /API/data, which returns some sample data. This function takes no input and responds with another JSON object containing a key data and the text "This is data from the FastAPI backend." Our Python backend is now complete. Let's move on to the frontend. Inside the src folder, there is a file called app.jsx, which is where we will write our frontend code. This file initially contains the default code generated during initialization. Let's run this code just to see how it looks. To do this, we navigate to the frontend directory and run npm run dev. The frontend is now running locally on port 5173. However, let's set a fixed address for development. To do this, we need to edit the vite.config.js file. Inside defineconfig, we add the server section and set the host to 127.0.0.1 and the port to 3000. Now, when we visit http://127.0.0.1:3000, we should see the default frontend, confirming that the initialization was successful. Now, let's work on the frontend to fetch and display data dynamically. The frontend is built using React, and our goal is to create a simple yet functional interface that communicates with the backend at http://localhost 8000/API/data, retrieves data, and updates the UI accordingly. We begin by importing useState and useEffect from React, as these are essential for handling state and side effects. The application needs to store the data received from the backend and update it whenever necessary, which is why we initialize a state variable. At first, this variable is set to an empty value since no data has been fetched yet. Once the component is mounted, meaning it has been rendered on the page, we need to make a request to the backend. To do this, we use the useEffect hook, which ensures that our fetch request runs only once when the component loads. We send a request to http://localhost 8000/API/data, where our FastAPI server provides the necessary data. After receiving a response, we convert it to JSON format and update our state with the fetched data. This process is completely asynchronous, meaning the UI doesn't freeze while waiting for the response, it simply updates once the data is available. The UI component returns a simple layout containing a heading and a paragraph. The heading displays the title of our project, giving context to what the application does. Below that, the paragraph is where the fetched data is displayed. Since the data is stored in state, it updates dynamically as soon as the response is received from the backend. Initially, this paragraph is empty, but as soon as the request is completed, it fills with the content provided by the API. If we run the frontend now, we should initially see only the text K tips Python React. However, to display the data from our backend, we first need to start the backend server. To start the backend, we open a new terminal, navigate to the backend folder, and run uvicorn app main app host 0.0.0. 0 port 8000. Reload. This command starts our FastAPI application using uvicorn as the ASGI server. The app main app argument tells uvicorn where to find our FastAPI instance inside app/main.py. The host 0.0.0.0 option makes the application accessible on all network interfaces. The port 8000 flag ensures it runs on port 8000, which matches the one we query in the frontend. Finally, the reload flag enables automatic server restarts when code changes, useful for development. Now, when we visit http://localhost 8000, we should see Hello K Tips Community. If we navigate to /API/data, we should see the JSON response from our FastAPI backend. Now, let's refresh the frontend. Since the data queried from the backend is not appearing, we need to configure FastAPI to allow requests from the frontend URL. We import CORS middleware from FastAPI, which handles cross-origin resource sharing, CORS. The app_add_middleware function adds CORS support to the FastAPI app, permitting requests from any origin, denoted by asterisk. After refreshing the web page, the output from the backend appears. This is data from the FastAPI backend. So far, we have created the Dockerfile and devcontainer.json, added the necessary VS Code extensions, and reopened the project in the dev container. The Python backend and React frontend are now set up and working together. Now, the only step left is to publish everything to Git. This will be the last, but definitely not least, part of this video. I'll include the link to the GitHub repository in the description. Feel free to check it out, as its README file will describe how to get started. I already have an account, so I log in, navigate to my repositories, and click New to create a new repository. Let's call it devcontainer Python React. I'll keep it private for now since we don't want to publish it without verification. I add a README file, and since I mainly code in Python, I select the Python template. I choose the Apache license and then click Create Repository. Once the repository has been created, you can click on Code to see the HTTPS URL. We'll need this later to connect the project we have on our local machine to this GitHub repository. Now we'll set up the project on the local computer to point to this repository. I do this inside the dev container as well, so I need to install Git inside the container. You can do this directly in the terminal inside the container, but since my container setup is still small, I'll add it to my Dockerfile and press F1 to rebuild the container. After the rebuild, let's verify the installation by running git version. We installed version 2.30.2. Now we can run git commands to prepare this repository. We start by running git init, which initializes a new Git repository in the current directory, allowing version control for the project. With git add, I stage all files in the current directory, preparing them for the first commit. Let's try committing now. I run git commit with the message initial commit. Git asks me to set the credentials. I'll do this off camera, just follow the steps provided. They might vary depending on your login configurations. Once the files are committed, I'll tell Git to link the local repository to the remote repository using its URL. I go back to the project in my browser, click on Code, and copy the URL. I use git remote add origin to link this URL. Now let's check the default branch that was created when I made the project, its main. In VS Code, the default branch is set to master, so we need to synchronize. Let's secure our local work by first pushing to the master branch. I allow the VS Code extension, one of my top 10 extensions, to sign in. I'm redirected to the browser to confirm, then redirected back to VS Code. To verify if your changes are on the master branch, navigate to the corresponding branch. Here, we can see our changes. Next, let's pull the main branch into the master branch since it contains the license and README generated during the repository creation. We do this by running git pull origin main. It complains about unrelated histories, so let's add the allow unrelated histories flag. On my local repository, the master and main branches are now merged into the master branch. Let's first push it again to the master branch. With git add followed by a def, I stage the new files, license and readme. With git commit I commit them, and with git push I push the merged local master to the remote master branch. This might be a bit confusing because we have two branches. You can keep it this way if you don't want or need to always publish your changes directly to main. For this project, since it's just a template, I'll change my local branch to be main. I use git checkout main for that. Then, I pull the remote master branch into the local main branch. Now, the local main branch is up to date with both the local and remote master branches. Next, we have to push these updates to the remote repository using git push. Since we are working on main locally, we don't need to add the origin flag. We can verify in the browser, and as you can see, the main branch is now up to date. Recap: in this tutorial, we set up a full development environment with a FastAPI backend, a React frontend, and a dev container to keep everything isolated. We also configured Git and GitHub to manage our project efficiently. We started by building our backend, created a frontend that connects to it, and finally pushed everything to a GitHub repository while managing branches correctly. If you followed along and completed all the steps, congratulations! You now have a solid setup for Python and React development in a containerized environment. If this was helpful for you, leave a like to support the channel. Feel free to share it if you think it can help someone else. Subscribe, as we will be working on optimizing this setup in upcoming videos. If you have questions, let me know in the comments, and I'll try to answer them. Happy coding and debugging with K-Tips. See you in the next one.